4.7 talks about logarithmic scales. I'm just going to talk one application. The pH measure. The pH measures how something acidic or neutral is, or basic is. It works on a scale from 0 to 14. Seven is the neutral. Anything below is acidic, and anything above is basic. So the formula for that is given by this. That will be provided on your test. You need to memorize that. The pH, which is the pH measure, tells you how acidic something is negative. The log of H positive is called the hydrogen ion concentration. Fancy. So pH measure how acidic or basic a substance is by measuring its hydrogen ion concentration. So either they give me the pH, I'll tell them the hydrogen ion concentration, or they give me the hydrogen ion concentration and tell them how acidic that is. So, first problem, example 1. An unknown substance has a hydrogen ion concentration of 2.3 times 10 to the negative 8 molarity. You don't need to know that, what those terms are. Find the pH and classify the substance as acidic or basic. It could be neutral. Well, we know that pH is negative log of the hydrogen ion concentration. So the pH is going to read negative log of 2.3 times 10 to the negative 8. The pH is going to be, and no big secret, there it is, negative, not this negative, this negative. Anytime you start with a minus, the statement with a you need, anytime you want to start the statement with a negative, you start with this minus, not this minus. It's always in parentheses in most calculators. The log, there's the log, that's base 10. It doesn't say that, but that's what it is, of 2.3 times 10. I'm going to write it, there's a key for it, but times 10 raised to the negative 8. 7.6. Remember, 7.6. 7 is neutral. It is considered basic. It's leaning more toward the basic. It's very close to the neutral mark. Beer has a pH of 4.6. Find the hydrogen ion concentration. Well, pH equals negative log of hydrogen ion concentration. If I told you that the pH is 4.6, well, guess what? This is a log equation. What do? You isolate the log by itself. The base is a 10. The base of the log becomes the base of the exponential on the side that's not a log, if you recall. So this becomes the base of the exponential side that's not a log. The side that's not a log becomes a power. And the argument stays where it is. And there it is. Now if you plug this in a calculator, it's going to give you something slightly different. 10 raised to the negative 4.6, 2.5, 2.51 times 10 to the negative 5, 2.51 times 10 to the negative 5. Either of those answers are accepted, but this is in scientific notation. And that's all we have for this section. Just want to introduce this scale slightly, and that's about it.